Next experiment is interface the internal DAC and generate triangular and square waveform. So you are connecting the output of P0.26 to the oscilloscope on the kit. If you want to observe on the oscilloscope, we will show the output on the simulation. So we will show in the peripheral or logic analyzer window on the simulation part. Now we'll go for the program execution using Keel Microvision 4. This is the program for triangular waveform generation using internal DAC, that is DACR register, which is present within DAC block of LPC 1768. So as the previous programs, you are going to add the startup file as well as the system file. Along with that, you are going to add the C file to the source group and then do the target settings, options for target. In that, go to output, click on X file and go to linker and then use memory layout. So once that is done, you save this and then compile it, check for any errors. So if there are no errors and the X file is created, this X file can be downloaded to the kit and observe the output on the oscilloscope. Otherwise, you can observe the output here itself. So to check on the simulation, go to debug, start or stop the debug session. Say OK. Here you observe the output using logic analyzer. So once you get your debug session, okay, this is your logic analyzer window. So I've already clicked and opened this logic analyzer window. Now you go to setup, in that you have to type it as, I'll show you this, click on this, insert new DACR register, press enter. So you can see your DACR. Now you click on this, give a maximum of 4 Fs, that will be equal to 65,535. So it varies from 0 to this range. Now once the setup is done, you can run the program. When you run the program, you can see your triangular waveform. Okay. Once this is done, if you want, you can stop and check for the frequency. You can click here and then observe the difference between the two. You will get the difference here. You can see the difference. See the difference between the two, and you will get the time period. So once you get the time period, calculate the frequency of the triangular waveform generated.